Okay, in this video, scientists, I would like to show you again how to use the acceleration equations to determine the distance an object moves while accelerating, or if you know how far they go and how long it took, the acceleration that the object was experiencing as it moved. So this first problem says a 1983 Buick Century, driven by Mr. Ziaddy's grandpa, accelerates at a rate of 1.9 meters per second per second. How far will Grandpa Bob's Buick move in 10 seconds while accelerating at this rate? So just like the constant velocity motion equations, you're going to identify what you know first. Okay? So this problem gives us an acceleration and it gives us a time. So you're going to write those things down. Let me get my marker ready. Let's do blue. Okay? We know the acceleration is equal to 1.9 meters per second per second. And what that means is that every second, Grandpa Bob's Buick increases its velocity or its speed by 1.9 meters per second. And we know we want to find out how long or how far it moves in 10 seconds. Okay? So the need to know is in the last sentence, how far. So we need to know a distance. Now, just like the constant velocity equations, the need to know tells you which version or which equation you need to use. So let's take a quick look at our equations here. We have two equations here involving distance, acceleration, and time, an equation that involves distance, velocity, and time, and then two equations that involve acceleration, velocity, and time. So in this class, you are required to be able to use these two equations. So what we want to figure out is which of these we use. And since we want a distance, we use the equation with distance on the left by itself. Okay? So this equation says the distance an object moves is equal to half its acceleration multiplied by its time squared. Okay? So that tells us that the distance an object moves while accelerating depends on two things: how fast it accelerates and the time that it's accelerating. Okay? So we'll go back here. We're going to write down our equation. D equals 1/2 at squared, acceleration multiplied by time squared. And then I'm going to substitute in what I know for the variables in the equation. So the distance is equal to, I'm going to write 1/2 as 0.5, and I'm going to use parentheses to show multiplication here. Okay, so 0.5 multiplied by the acceleration, 1.9 meters per second per second, and I'm including the units as I do this. It's good, best practice when solving a problem like this. Multiplied by the time squared. Instead of writing 10 seconds squared, I'm going to write 10 seconds multiplied by 10 seconds, because that's what squared means, the number multiplied by itself. That way I've set up my problem so I can use a calculator just to multiply through 0.5 multiplied by 1.9 multiplied by 10 multiplied by 10. Okay? So I'm going to pop up my calculator. I'm going to do the math, and then we'll get an answer. And since I'm finding a distance, my answer is going to be in meters. So 0.5 times 1.9 times 10 times 10 gives me 95 meters. That, my scientist friends, is our answer. Okay? The Buick Century can go 95 meters in 10 seconds if it's accelerating at a rate of 1.9 meters per second per second. All right, let's look at another one. Grandpa Bob got some work done on the Century. Now, after 10 seconds of acceleration, this fine machine can travel 175 meters. What is the new acceleration of the car? Okay, so what do we know? We know a time and we know a distance. Okay, And it says, what is the new acceleration of the car? We want an acceleration. We need to know how fast Grandpa Bob's Buick's velocity is changing now that it's all souped up. So I'm going to write down my knowns. Time equals 10 seconds. And distance equals 175 meters. And we need to know an acceleration. And again, the need to know tells you which equation you want to use. Let's go back to our equations and look for the one with acceleration on the left. Okay, here we go. Acceleration equals twice the distance divided by the time squared. Now, this one has acceleration on the left too, but we don't know a velocity. So this tells us that this is the equation that we're going to use. All right, write that down. Acceleration is equal to twice the distance divided by the time squared. And then again, I'm going to plug my knowns into my equation. So I'm going to rewrite my fraction, 2, using parentheses to show multiply, 2 times 175 meters, divided by time squared. So again, I'm going to write this as 10 seconds multiplied by 10 seconds. Now for this problem, I want to do the math on the top and do the math on the bottom and then rewrite the fraction before I divide to make sure I don't make any mathematical errors. So to do that, twice 175 is 350. So 350 meters on the top. Divided by 10 seconds times 10 seconds. And I'm going to write that as 10 seconds squared. Or 100 seconds squared, I'm sorry. And then it's a simple division. 350 meters divided by 100 seconds is 3.5. Now, this problem tells us that the unit is 3.5 meters per second squared, but that means the same thing as 3.5 meters per second. So when I write my answer, I can write my unit for acceleration like that. All right, so Grandpa Bob's new Buick, or souped up Buick, accelerates almost twice the rate as the Buick did before he got it all fixed up. Okay, hope this helps. Thanks.